Hi, I'm Lauren Wells, and here's a little bit about my experience interning at Space Center Houston, summer 2019. So a little bit about me. I'm a sophomore at Baylor University, majoring in mechanical engineering and mathematics. In this upcoming fall, I'll be researching at the Baylor Research Innovation Collaborative, or the BRIC as we like to call it, doing robotic systems research. And I hope to one day develop space robotic systems. I have loved interning at Space Center Houston, mostly because I just think space exploration is cool, but I just love that every day we get to develop programs that show students how they can achieve their own scientific goals, and everything is within their reach if they just persevere through the math and the science. And here we get to show students how they can do that for themselves. And it can be extremely fun. And I just love how every one of our projects, we get to be creative with them and make them our own. And it's so easy to do that in this work environment because it's so upbeat, so inspiring, and we're surrounded by people with the experience in this field where they've worked on these types of projects in real life, and they are so happy to give us advice that we need to make our curriculum for the students as accurate and scientific and enjoyable as possible. And I just love it. And it's and we get to go on these experiences where we can see how the systems that we're trying to simulate are integrated into real life, and we can take the science and math and do it ourselves, and it's amazing. So this summer I got to work on atmospheric research and continue doing that from last year, but even bigger with 4 weather balloons instead of 1. And I helped Catherine Wood develop the Mission Control Space U, which simulates the Artemis program. So that was awesome. So with Mission Control Space U, we simulated the upcoming Artemis program, which is a series of missions leading towards lunar habitation and towards the Gateway program. So with our program, the students can learn about 4 different divisions of the space program that work together by being a part of one of them. So based on what each student feels more comfortable with, whether engineering or leadership or experiments in science, they will be sorted into 4 different divisions, including Johnson Space Center's Mission Control Center, or JSC's Mission Emergency Room, which is more like engineering, and JPL, or Jet Propulsion Laboratories Robotics, or the Astronaut Corps. So we sometimes simulated the unexpected hindrances that NASA has to solve on the fly and work through and problem solve together by giving them problems that they might encounter in space and that sometimes have happened on the ISS, or those types of problems that they would need all 4 divisions to solve, so that way they could practice having to problem solve together and having to communicate with each division given the materials that they have, or given the communication devices that they have. So part of that problem was being able to have a solid foundation of procedures, a solid foundation of communication, and do this all amidst lunar science experiments and trying to complete their mission at the same time as making sure their crew is safe and making these habitat damages repaired. Some of these divisions, such as Mission Control Center, if you were in that division, you would oversee the mission, you would make the daily plans that the crew would have to perform, and have to make really tough decisions, whether it was a loss of crew decision that, okay, we cannot go forward with this experiment because the crew's lives might be in danger, so we'll have to forego the mission, or we'll have to forego this experiment to preserve the health of the crew. And another division, JPL, would, before the crew would land, they would conduct a drone survey and make sure that the Sea of Tranquility had a nice suitable spot for them to land, and also control the rovers, not only before the crew landed, but also maybe while the crew landed. They would help them see wherever there was radiation spots or volatile spots in other ways, and and how they would go about doing that. The astronaut corps followed an OSTPV, which is an onboard short-term plan viewer, which currently the ISS astronauts are viewing now. They often find that they can optimize their time if they have a really easily adjustable schedule where if something goes wrong, or they have an OBE, overcome by events, situation where they have to move on or move something around, they can use the OSTPV to easily do that. So they would conduct science experiments on the lunar surface, and also, of course, live on the moon for a few hours, and have to construct their own habitat, which the MER would make, and figure out how to make the best airlock, and do that with a limited amount of materials and a limited budget. So this is trying to simulate the real constraints of a mission in real life. So as I said before, the challenge was not only to perform these science experiments and their duties, but also to coordinate solid communication in each activity and follow their own procedures and chain of command. So atmospheric research, Space U, was really cool because we got to launch 4 weather balloons with 120 students. And so there were so many types of experiments, and recovery was really fun as we got to travel and recover all these balloons payloads successfully. So the students got to do their own ascent and descent calculations and find out how much helium they would need to lift the balloon given their mass of their payloads and experiments, and the whole mass of the balloon, and include how drag force would affect the dynamics of their balloon as it travels through each layer of the atmosphere. So I find that this is a really good Space U because I think it helps the students understand how they can do the math and do their own research if they enjoy it, and do the science on their own if they decide they want to conduct near space research or do this on their own. It's very easy to do on your own, and I think it can inspire some students to space exploration too. So our students launched insulation material experiments and pressure experiments. Some of them sent up a bag of chips, and so that was neat because it sounds like low experiment with not a lot of materials like that you would need to buy, but you could see how a bag expands as the air became less dense as they traveled into the atmosphere. The pressure would interact differently with the altitude, so the bag expanded, and they got to see that since they put a camera inside of the payload instead of outside it. So that was neat to see how the air density changed, and they could see that, a visual representation of that, not only just knowing it from some equation, but they could see that in real life. And some viscosity experiments were fun. They sent up slime and saw how the viscosity would change. And students ran their own weather predictions and their own flight path predictions, and they stayed within the FAA regulations, which is always nice. so we can continue to do this. And they formed their own teams of weather forecasters and flight predictors and engineers. So they collaborated very nicely to make sure they had a successful balloon launch. And that's our recovery. We recovered all 4 payloads, all 4 balloons and their individual payloads. So with this camp, because it was a larger camp than last year, we learned a little bit how to accommodate for larger groups, and we bolstered the math tutorials, as it was needed for students with different math comfort levels. And with this, with more students, our team was able to develop more ideas for experiments to test in the atmosphere in the future. And we're real excited for how many more experiments can be done, seeing as how there were so many experiments already that happened this year that were new. So with this summer, as I said before, the more students that we had, the more we saw we could make a more in-depth tutorial of the ascent and descent rate calculations for the physics portion of the atmospheric research Space U. So we worked out some logistical procedures of this camp as well, because of the size of the camp. And with the Mission Control Space U, we found that it was very relevant per the Rising Artemis programs. And I think it'll inspire students from around the world to see how joining this mission is within their reach in the future. And it's coming up, and the Gateway program will involve international companies and international government space agencies. So this will be a very exciting to see how this camp can impact students and their excitement towards space exploration. And this summer, I've just been so inspired myself, seeing how just a few of NASA's multitude of centers can work together to challenge the scientific and mathematical boundaries of our knowledge. I was so inspired by the MCC camp. That was inspiring to me personally, and I can't wait to see more research opportunities at my university. And overall, this internship has introduced me to so many different subjects of research, such as Dr. John Charles' twin study and his findings on the telomeres, how it impacts aging of our DNA, and just being able to do more math with the atmospheric research program. It was great. I've just loved Space Center Houston's environment. It's such a lively environment of productivity and fun and joy, and you can just be as creative as you want and do as much math as you can dream of, and this has really just shown me how much adventure there is in science, and especially thanks to Casey Hines, my wonderful boss. She has shown me how much adventure can be in science, and it's so cool. We got to do helicopter escapes and launch weather balloons and go in fields and find these balloons, and it's just been so great. What I really loved in the astronaut breakfast is whenever a student would ask, what can I do to become an astronaut, their advice was always something like, do what you love to do and find what you're passionate about and study that and become good at what you love. And that way it's never work. It's already what you love doing, and you can easily become good at that if you persevere in that. So I thought that was always nice, and I love seeing the community come together during the Apollo 11 50th anniversary. And I got to meet my lifelong hero, astronaut Fred Hayes. And of course, I made lifelong friends that I will never forget. So, thank you, Space Center Houston.